Hello everyone, my name is John Bussard. I'm an HPE Business Transformation Center engineer for Ingram Micro. I help support HPE servers, blade system storage, as well as Aruba networking technology solutions. In my videos, what I like to do is show you a slide from a popular HPE PowerPoint and demonstrate to you what that means within a management context. Today, we're going to continue on our conversation with HPE ProLiant systems and Intel Optane storage solutions. In particular, we're going to be looking at the Intel Optane Persistent Memory Solution, or PMem solution. So today, when we look at SSD drives or flash drives when we're installing our system, certainly they are, differentiating as far as performance impact, as far as our applications in our environment. But they're kind of being held back by being connected to the SAS or the SATA bus within these compute environments. So we're really looking for different ways in order to be able to connect this storage technology in our environment to really unlock the performance of these solutions. Now, Intel Optane Persistent Memory connects to one of the fastest buses in our system, our memory bus. So this solution actually are sticks of modules that go into the memory slots on your server. And if you install them, they'll act as very fast storage. And what I'm describing here is app direct mode. So if I install them, boot up, say, a Windows server, they would show as a drive inside the environment, and I could format that out as like a D drive or an E drive or something like that. So that's app direct mode. Another way we can utilize these modules is in memory mode. Right, so this will act like memory extension. So why would we want to do that? Well, these modules, come in a variety of sizes, and as this writing, there is a 128, 256, and 512 gig, which obviously are much larger than our traditional DRAM offerings, our DDR offerings. And what we can do is install this inside a system, right, and really extend out our memory footprint at a lower cost. And generally speaking, what I've seen is twice the size of Intel Optane persistent memory will cost you about half the price of a traditional DRAM module. So certainly we could get a lot more memory inside our system at a reduced cost. Now, in either one of these modes, you're going to need traditional DRAM inside the system, DDR RAM inside the system, in order to be able to accommodate normal compute, and especially true in app direct mode. In memory mode, it's not so obvious. You do need to have regular DRAM in there, and that'll act as a caching mechanism for Intel's Optane persistent memory. Now, persistent memory isn't quite as fast as normal DRAM, so again, it uses the normal DRAM as a caching mechanism. And a basic rule of thumb is you want a 4-to-1 ratio. So for every 1 gig of traditional DRAM, you want 4 gigs of persistent memory. But there are other ratios that are in there that I would recommend looking at the documentation that's wrapped around it. As a matter of fact, the installation of this RAM, obviously there's rules that are around persistent memory, and as well as regular memory modules and how they get installed in the server. So you certainly want to go look up that documentation to make sure you're installing it based on best practices within your environment. The only other thing that you really need to take advantage of this is you're going to need an Intel Generation 2 scalable processor in order to be able to utilize this. So in our environment, I have a vSphere cluster that we're going to be looking at, a couple of ESX hosts controlled by one vCenter. And one of those systems I have, a 1.5 terabyte in memory mode of Intel Optane persistent memory. Now the other system, I've taken the 1.5 terabyte and I've divided it up, and I've put in what's called a mix mode. Most of the memory is going to be in memory mode, but a little bit is going to be in app direct mode. And I'm going to show you how this interacts in with a VMware environment, a vSphere environment. I'm actually going to pass that direct mode memory directly into a virtual machine, and we'll take a look at some of those metrics. So with all that being said, let's explore this management context. Okay, here we are at the ILO interfaces, and again, I have an ILO interface for each of my ESX systems here. If you don't know what ILO is, it's a baseboard management controller that exists on HPE ProLiant systems. Basically, you can log into this even when the server's off and tell if everything's okay within your systems, the power supplies are working, the fans are working, things like that. It also gives us a view into how components are installed into our system as well, and that's how I'll use it today. If you buy an ILO Advanced license, you can actually get a graphical user interface into your environment. So what does that mean? it will, logging into ILO and opening this up, it can act like I'm directly connected to a keyboard, monitor, mouse on the system, but through a web browser, kind of like an IP-based KVM type of solution. All right, and we'll utilize that as a part of this process as well. So let's log into this system's ILO interface. And then what we're going to do is we're going to go over here to system information. And the first thing I'm going to check is my processors. See, I have 2 processors installed, and there is certainly the 2nd generation of Intel Xeon scalable processors. Tell by that number there. Let's go take a look at the memory and how the memory installed. Now this system here, all the memory is in memory mode. So if we scroll down, what we'll see here is kind of that 4-to-1 ratio kind of going on. So even if we look here, we can see I've got a 32 gig of RDIMM. If I select that, we can see that's a Samsung chip. And here I have a 128 gig of PMem, which again, we can see that's the vendor's Intel here. So basically, this system has 24 slots in it, 12 per processor. Half of those slots are filled with 32 gigs of traditional memory. And the other 12 slots are filled with Intel persistent memory. So I've got 384 gigs of traditional memory, and I've got a terabyte and a half of Intel Optane persistent memory, PMem solution inside this. All right, so now that as compared to this system here, so this would be my secondary ESXOs. So let me log into this guy. Now this guy's configured just a little bit different. I'll go over to system information and we'll go directly over to memory. This guy isn't on yet. We're going to turn him on. I'm going to scroll down a little bit here. You'll see again all my memory slots are filled. Again, we can see the Intel Optane persistent memory here. And again, I have a terabyte and a half of that installed. But because I'm using some of this terabyte and a half in persistent mode, and I want to maintain that 4-to-1 ratio for memory mode, right, I had to reduce the RAM a little bit inside our environment. So that's why you see these 16 gig modules, and I got 4 16 gig modules, so I reduced that by 64 gigs, and obviously I have 4 times that set aside for persistent memory inside this environment. So again, look at the rules, download the memory guide, understand how this memory gets installed and configured for your environment. All right, so what I'm going to do here is we're going to open up a graphical user interface into this environment. So we'll do it through HTML5. And then what I'm going to do, because this server is not on right now, is we're going to power this guy on. So we'll do a momentary press. And we can see it go through the boot process. Let's maximize this window. Now I'm going to cut out a little bit of time as far as the boot process is concerned, because I like to keep the videos kind of short, get to the information that you guys need. This boot's kind of quick, but not quick enough for what I'd like inside a video. So again, I'll trim a little bit of that out. Now I'm going to go into system utilities, but real quick, we can see the installed system memory is 320 gigs on this system. Available system is about 1/3 of memory. Installed persistent memory is 1.5 terabytes, and the available persistence is about 156 gigabytes. So I've got this carved out, and I'm going into system utilities so you can see how I did that. Okay, we're up here in system configuration. I'm going to select that. And then we're going to go into the BIOS platform. And then we'll go down to memory options. And here we can see persistent memory options down below. So I'm going to select that. Let me get a little bit of information, but really I want to go into PMem options. So I'm going to select that as well. And here we can see DRAM used as part of PMem cache. Again, that's at 320 gigs that I have installed of traditional RAM. So obviously that'll be the caching mechanism for this. And then PMM volatile size, again, this is the memory that will not retain its information on a reboot, is about 1.3 terabytes. So it's a lot of memory to have inside a system, right? And this is what we'll present to the VMware environment. If you look down below, we can see the persistent memory size that I have and how it's divided up between the 2 processors. And if I go to goal configuration down here, I can select this, and this is where I divided up what I'm using as volatile memory or memory in memory mode, as well as persistent memory or in app mode. And I got different things that I could choose over here, but there's certainly a ratio that we want to maintain in here, and I've done that. If you do look at this will be about a 4:1 type of ratio that exists. All right. So let's get out of this. I just want to show you how that was configured. We're going to exit again, and back right on out of this guy. One more time, and yes, we're going to reboot. So now this is going to boot into VMware, and I'm going to cut this out because obviously I'm going to have to let the vCenter environment settle a little bit and figure things out. So I'm going to kind of cut this video, and I'm going to come back into the VMware environment, and we'll explore how this looks within the infrastructure. Okay, my vCenter environment's up. I've taken my host out of maintenance mode, and this is that secondary host that we booted up. Let's take a look at the first ESX host within this cluster. And we can see down here what it's presenting. Its memory, it's just about 1.5 terabytes of memory. We get no visibility into the traditional RAM in the environment because, again, that's used as a caching mechanism. But still, I have 1.5 terabytes of memory inside a ProLiant server that didn't cost as much as traditional RAM. So that's how I'm utilizing it in this. Now with this system here, you remember I had some of it carved up in memory mode and some in persistent mode. So again, we could see that here. So we could see that this system sees about 1.3 terabytes of memory in memory mode, and then PMem or persistent mode memory is down here. And I've got about 155, 156 gigabytes of memory installed here, or persistent memory installed that I can utilize. So how does this get utilized? Let's first talk about the memory in memory mode, or persistent memory in memory mode. What does this allow me to do? Well, today VDI is a pretty popular solution, and really the density of our virtual desktops really comes down to the amount of RAM we can afford to install in our system. But in this environment, I have well over 200 virtual desktops kind of running in this environment. All right, so having this extra memory has allowed me to be able to configure these virtual desktops in a particular way. So if I'm going to take one of these, we're going to right click, and I'm going to go down to settings. I'll edit them real quick. You can see I got 4 GPUs, but more importantly, I got 16 gigabytes of RAM per virtual desktop, and I could actually probably spool off some more virtual desktops if I wanted to. Another thing that I've utilized this persistent memory for, this persistent memory in memory mode, is for 3D memory on the video card. Right, so this certainly is performance considerations around graphics with virtual desktops, and you can have something that's very basic within a VMware environment. I've extended out the 3D memory to its maximum, which is 2 gigs. So I use this as kind of a stopgap measure before I go to something that's very expensive, something like an Nvidia GPU solution installed in this. Right? So that would certainly be another option. That would be the ultimate performance. But this will get you somewhere, I'd say, in the middle as far as performance is concerned. If you think about it, each one of these virtual desktops I have inside this environment has about 18 gigs of that PMem allocated to it. So it allowed me to be able to get a very large environment with very robust systems. I'm also doing something else against these systems. I'm running VMware Planner on these systems. If you don't know what VMware Planner is, I've got that open over here. What it is a way of kind of benchmarking virtual desktops in the environment. So VMware Planner will actually go into those virtual desktops that I had and actually start utilizing them. It'll do different things like open up a PDF document, scan through it, open up a Word document, scan through it, open up different Word documents, maybe open up Outlook, things like that. So it'll simulate kind of a workload, and it'll do that in a randomized fashion across all these virtual desktops that we have in the environment. And this guy's running well. Could probably spool off a bunch of more virtual desktops if I felt like it. Another thing I want to show you as a part of this, and this is one of the reasons why I'm running this workload against all these virtual desktops, is I want to show you how to use the memory that I've set aside in persistent mode. Again, this will survive a reboot cycle of this system. So I can take that and I can dedicate it to virtual machines. And I have some virtual servers in the environment. That's kind of not a best practice as far as a virtualized environment. You kind of want to keep your servers separate from your virtual desktops, but I've done that here again so I can get a workload running across them. And I've got 4 Windows Server 2019 incidents running here, and let's just take a look at one of these. So I'm going to right click on this guy, and we're going to go down to Edit Settings. We're going to see this guy has got 8 CPUs, 16 gigs of RAM, not a real lot, but I have an Nvdimm, so I could go over here, add a new device, and I could add an Nvdimm controller to this system if I wanted to. If I expand this on out, we'll see the available persistent memory, what's supported by guest, and then what the VM actually has. So I've assigned 32 gigs of persistent memory to this virtual machine. So again, this is reaching into that persistent memory off the Intel Optane PMem solution and using it directly inside a Windows desktop. So let's take a look and see what this looks like inside the Windows environment. So we'll select this system here. We'll open up a console to this guy. Right, and then we'll go over into disk management. And then we'll see it is, it looks like a regular drive. I can format it on out. Again, this is coming from the PMem architecture from storage that's connected directly to the memory bus within the system. Right, and I can get great performance out of this as well. Right, and I'm going to run this across a few systems to show this is a pretty consistent way of getting performance across virtual machines. And again, keep in mind that in this environment, this system's not very robust, right? But I also have, all those other 200 virtual desktops kind of, running their workloads as well. So what I'm going to use to benchmark this is, it's an older utility from Intel, but I kind of like it. It's called iometer. I don't necessarily want to make you an expert in this, but I want to get your head wrapped around just so there's no smoke and mirrors or anything like that. So basically what I'm going to do is I'm going to take these workers, basically one for every core that's inside the system, or every virtual processor that's in the system, and I'm going to run it against this storage. I'm going to do 100 outstanding IOs. Right, and I got to come at it, is it read, write, is it random, sequential, and that's done under access specification. And I have this access specification here, and again, just so there's no smoke and mirrors, let me edit that so you can see what's going on. So I got 80% sequential, 20% random, 80% read, 20% write. A little storage friendly, but this will work for us as far as what we're doing. All right, so let's fire this up. I'll click save, and I'll watch the performance kind of stack up. So we're already getting about 50K IOPS out of this guy. I've seen this guy go between 50 and 60K IOPS. But usually if I run extra workloads in the environment, I could expect to see a reduction in performance across virtual machines in the environment. Again, this is one host with a little bit of persistent memory carved out from our Optane PMem solution, persistent memory solution. So let's get other virtual machines that are running across the same storage that we've created out of that. All right, so let's go back over here. Let's go to another system. This system is configured exactly the same. And again, we're just going to open up iometer. All right, we're going to set our workload, run it against the storage. We'll fire this guy up. Once again, we're getting about that 50K IOPS, so no reduction in performance across either one of these systems. All right, so let's do that again. Let's grab a third system. Right, again, we'll run iometer. Got all these workers. We're going to come against in another 32 gig space. We'll fire this guy up. We'll click save. Again, we're getting close to 50K IOPS. Right, so no reduction in performance. So far, we got 3 systems. So let's go for the 4th system. This is my last system because this is kind of all I've carved out as far as persistent memory inside this solution. So let's open this guy up. Again, expand that out. We got 8 workers. We'll come against PMem storage. Again, that 32 gigs I've allocated. We'll run that. And again, we're getting 50K IOPS. So this guy's peaking up almost 60K IOPS. So across all of these, right, we haven't reduced performance. And I would say 50K IOPS, from any storage solution is a respectable amount of performance. And here we've got an aggregate across all 4 that's almost 200K IOPS. All right, so that's a nice amount of performance. Again, this is a single system with some Intel Optane PMem installed in it, so this would be great. So how can I utilize something like this? Well, databases would love this type of performance in their environment. You can use this maybe for the log files or something like that. There's a variety of ways we could use this as far as a database is concerned, but anything that could use, you know, a little bit of very fast storage as a part of its computational capabilities, you know, this is going to make a great solution. So that's the different ways you can use Intel Optane persistent memory solutions or PMem solutions. Again, you can use it in app direct mode, so directly creating storage off the memory bus, or you can use it in memory mode, giving you a low-cost way in order to be able to provide additional storage memory capabilities in conjunction with storage within your virtualized environment. Again, this was a VDI environment. I hope you guys found this video informative, and please stay tuned for more videos.